Okay, good afternoon, everybody, and welcome to Training Tuesday.
That's right, Chuck, and good morning to all you guys on the West Coast. Um, you just heard Mr. Chuck Hoke, and I'm Heidi Reese, Training Programs Manager. He's our National Training Product Manager, the brains behind the scenes. I guess I'm smart too, right, Chuck? Anyway, I want to go over a little housekeeping like we always do. I want to remind you that everyone who has been joined muted, but don't let that stop you from asking any questions. You can do that through the Zoom functionality, through the Q&A, question and answer, or chatting with the panelists. I'm the panelist, Chuck's the panelist, so it's only going to us unless you do everyone. With that too, just want to remind you that we record every one of these and put them out on DaytonSuperior.com, the YouTube channel, as well as the actual DaytonSuperior.com website. Just search on Training Tuesday and you'll find two links, one to get you to the latest and greatest four that we've done, as well as a place to register. And then you can use that and go to all the ones that we've done. We are actually finishing our last of the bridge deck for this month, sure to be really fun today. So yeah, let's get to the intro. We've got Mr. Chuck Hoke here. He's been in the business for like 50 years, so he really is the brainiac. He is so smart when it comes to the bridge decks. So many people call them because there's so many different variations and things to do as far as steel bridges or wood bridges and what's going on with bridge overhang brackets and this and that, that it's crazy. But like he likes to say, it isn't rocket science, and you can learn as well. So if you haven't already listened to the ones that we've done over the last Tuesdays of this month, be sure to get out there, like I said, in Training Tuesday and find the bridge deck, and you can get that. Today, we're going to be talking about estimations, applications, looking at the plans and takeoffs. And so with that, I'm going to pass it on over to Mr. Chuck, and he's going to take you through our presentation.
Okay, thanks, Heidi. Uh, as always, our presentations are intended for training purposes only. For technical specifications, please refer back to DaytonSuperior.com. Now, who is Dayton Superior? Well, Dayton Superior, we're the leading solution provider for the concrete construction industry. Products, support, engineering, and then training on top of all of the products, all of the support we give you, plus all of the engineering. Basically, our product lines include Dayton Superior, AccuBrace, TiltWorks, LabWorks, Cody Clip, Taper Lock, Sleeve Lock, Bar Lock, DBDI, Aztec, and then also on the chemical end of it, Dayton Superior Chemicals and Unitex chemical products. And let's not forget Simons, our forming end of the division. Basically anything for concrete forming, whether it be vertical or horizontal, we can get into shoring with deck fast, frame fast, highlight, drop head, shore fast, or even soldier beam with that. And obviously, we also have some steel ply, Simply, and Maxiform STS, along with Flexform, and then all the accompanying products that go along with that system. So, as Heidi alluded to, what we are going to talk about today is reading and estimating bridge deck plans. Now, the past month, we've been talking about how to do an interior, how to do an exterior bridge forming. So what we are going to look at today is so much taking those components that you've learned from the last couple of weeks and incorporate them in how to actually look at a bridge deck to do the takeoff. So bridge deck construction, it has changed and evolved a little bit over the years. We see a lot more cast in place, precast steel. We're actually seeing more laminated wood and also full precast concrete structures coming into play. Basically, you're going to have all of these supported. All of these items are typically supported on concrete or steel girders. Sheathing, obviously, we talked about with plywood, joists, ledgers, posts, typical cast in place structure items. And obviously all the overhang brackets and the accessories, the guardrail receptacles, the extensions. Obviously, the hangers come into play with that, along with the coil rod. And obviously, we talk in this session, we will talk a little bit more about bridge deck finishing machines and the loads that they're actually implying on regards to the overhang bracket. We have Simon's forming systems that we'll also manage to talk a little bit about, because basically every bridge deck has to have a good foundation. You got to build that vertical formwork. Simon's is a great opportunity for you to actually incorporate Simon's forms into your substructure, and then your superstructure, use the Dayton Superior to actually form your superstructure on that product. And then obviously we have chemicals to coincide with all of the systems that we're talking about, whether it be form release curing compounds, epoxy sealers, and actually finishing aids, etc. All those components typically fall in and underneath our umbrella with the Dayton Superior chemical line. And then to top it all off, we have a great engineering department to actually work on any of these projects here to do the takeoff, get you drawings, get you a layout, help you with any questions that you may have. Feel free to ask anything that you have here. What we are going to talk about here today is we have a variety of different states that we are going to highlight here. And this one here, I picked out New York State on this one because it's kind of where I started in this business, doing takeoffs and everything up in upstate New York, where we had a motto: if it had four walls on it, we didn't call on it. So we only did bridge and highway. So we were very familiar with the New York State DOT and their rules and regulations, and actually their traits of what they like to do. Now, every state is a little bit different. So, but the process should be the same on as far as if you're going to do a takeoff, where you need to start and what you need to look at. So typically here you look at an estimation here. We've got plans that we've got out here. You're going to want to review not a whole lot of drawings. I mean, basically you're talking a deck section and a framing plan are probably two of the most important ones that you need to look at. We're also going to show you how you're going to want to look at the beginning of the drawings, where especially in the structural notes that are out there, because you actually have to understand how the bridge, what the state wants to do with the bridge and their rules and regulations. And when we get into the structural notes, we'll talk a little bit about what you can find there, and where that information is going to be used from. But typically on your plan, on your deck section and your framing plan, you're going to get the overall length of the bridge, the girder details, because that's going to come into play, especially if you need engineering done. How thick the deck is, because you want to know how much concrete you're putting on top of the formwork. And then obviously the thickness of the beams, thickness of the concrete over the beams, which is going to give you what the haunch is of this structure. The bridge width comes into play a lot more than you think, because the width of the bridge actually determines a lot of times what finishing machine the contractor is going to use. And over the years, the finishing machines have evolved because, as I said earlier, bridges have evolved, where you typically had a 50 to 60 foot wide bridge. Now you're replacing that 50 to 60 foot bridge with a 80 foot wide bridge, or maybe 90 foot wide bridge. Add additional lanes to actually increase the width of the bridge to handle more traffic. Once you start stretching out those finishing machines, you've got to upgrade the finishing machine from like the C450 from Bidwell to basically like a 3600 or a 4800 type machine, which actually is a much heavier, but the heavier also means that it'll span farther apart. So that enables all contractors to actually accommodate what they want to do as far as how much bridge deck do they want to pour in each phase. You're also going to get rebar clearances from these drawings, both top, bottom, whether you have transversal bar or the longitudinal bar, especially the size. You're also going to get what type it is, whether it's black, epoxy coated, galvanized, etc. Those are all typically also denoted on these plans. And then obviously you're going to get any of the interior work if need be. And a lot of the structures here that we're seeing being constructed today, we're not seeing a whole lot of interior bridge deck forming going on anymore. Probably 80 to 90% of the structures that you're now seeing around the country are being formed with using SIP decking, and SIP stands for stay in place, or you're going to be using a concrete plank, which actually has replaced the corrugated metal decking, and actually gives you a thicker concrete deck in place. But it also allows you to inspect the bottom side of the underside of the deck so you can see what's happening to the concrete.
That sounds like a fun walk.
Yeah, that's a fun walk. Walk underneath the bridge and take a look up.
Yeah.
Yeah, and the thing of it is, my wife tells me I have no life because when I go out on job sites, that's kind of what I look at.
Yeah, we all do, don't we?
So from there, let's start at the beginning. Okay, when you get your plans, you're going to want to sit here. You're going to want to go. This looks like a bunch of jumble all the way around. But there's a lot of pertinent information in here. You're going to get information like what type of steel is going to be used, what type of steel has to be used, whether it's grade 60, grade 80, um, uh, whether it's black or epoxy coated. And any steel that is accompanied within the structure, any steel that may be exposed, does it have to be coated? Does it have to have an electro galvanized, or is it a hot dip galvanized? Those specifications typically vary from state to state, but they're always listed in the structural notes or the jobs notes within the set of plans. And typically these are usually the first half dozen pages or so. And what you'll also find on here is you'll find notes such as this, like metallizing. All girders, including stiffeners and connection plates, shall be metallized. Metallizing shall wrap 1 inch over the top flange. The metallizing shall be included in the bid price for an item number. Metallizing type 1. All primary and secondary metal shall be metallized, and the cost of metal shall be included in the bid price. So therefore, you're seeing what is actually included within the structures. But the big thing you hear on the bottom, all this material here, there'll be no welding to metallized or galvanized surfaces. So if there's any surfaces that are metallized, painted, coated, with either electroplated or just a epoxy coating, etc., you cannot weld to those structures. And it's kind of what you're actually seeing here. The one other note you're going to see here is the provisions for the specifications for the superstructure slabs allow the option of 3 forming systems for the slab. That's typical for New York State. Typical New York State is SIP decking, wood forming, and or another prefabricated system with a removable panelized system. On this bridge, only 2 of those options will be permitted. Either permanent corrugated metal decking, or SIP, and or removable wood forms. Now, the cost differential for the contractor on those is night and day. Corrugated metal decking is a lot cheaper than removable wood forms, because basically you have to construct the bridge, do all the form work, use all the lumber to form it up, and then remove it also afterward. The corrugated metal decking typically is the cost of the metal decking being installed once and done. So the labor cost for metal decking is much less than what it would cost for removable wood forms. So that's why the contractor a lot of times will favor the corrugated metal decking. So getting into the plans that we're looking at, the contractor has a cross section of deck. Now this is very, very similar to what you'll see on almost every set of plans. So this cross section here is usually pretty consistent across the board. You're seeing a crown point, a high point within the structure, and everything slopes off and away from that. Now the high point can be located to one end or the other. It can be 2/3 of the way, halfway around. Those are all things that the contractor will take into place when he says, because you want to have basically a decent slope to allow water drainage when it rains, so that everything will run off the deck. But you're also in this information, the information on this set of plans is, one, you're going to get the out to out here. You're going to get that. This one here will actually tell you how wide the bridge is. You are actually going to, and we're going to talk a little bit about this in a little bit here, but you can see that we have 5 steel beams on the structure here. And they basically make up that you got 9'3" center to center all the way across. What you'll also get here is usually in the framing plan, you'll get a steel beam design. Now, if it's a concrete beam, there'll be a picture of a concrete design, whether it's a type 6, type 7, type 4, type 5, or any other concrete beam that is pertinent to that region, that state. Like TxDOT has their TxDOT 28, and those beams here, all those beams are relative to the state and where they're manufactured and how they're going to be used. In New York here, this is a very typical structure. It has what I would classify as a 33-inch web. So the web, it has a height of 33 inches. And the structure itself is actually going to be 218 feet and 8 inches from end to end. And what that's going to tell you is that a 33-inch girder, the top beam flange is going to be 2-inch by 21-inch. So that means any hanger you put on here, if it has to go across the whole beam flange, it needs to be 21 inches and be able to accommodate a 2-inch thick beam flange. What you're going to see here is the bottom flange. I don't typically worry a lot on, because we don't actually do any forming off of the bottom flange, but the top flange is the one that we're most concerned with. And in this case here, it's a 2x21 with a 33, basically roughly a 33-inch web. Now, what that 33-inch web is going to tell me right off the get-go is my problem for the overhang brackets are going to be, I have to have 6 inches of formwork included with my overhang bracket. So my overhang bracket, if it is a C49, has a 30 to 50-inch adjustability. A C49, putting the formwork on top of it, will not accommodate, will not fit into this structure. So therefore, I'm going to know right off the bat that I have to use a C49S, which means it has to be field modified. But just give me one quick note that I know in my head, I'm going to place in the back of my head, and just know that when I move forward, it's going to be a C49S, probably set at about 26, 27 inches. With 6 inches of formwork on top. And the 6 inches of formwork that I have is the 1.5-inch nagel plate, a 4x4 lumber joist sitting on top of that, and 3/4-inch plywood on top of that. So what you're also going to get here is you're going to get the overall width of the bridge, or the length of the bridge. That's another note that you're going to place off to the side. So your bridge is 218 feet. Your top flange, as we noted right here, and the web there. Now, so you're taking those little tidbits of information I have. I know I have to use the C49S, so I'm going to get a quick estimate here on how do I get my C49S to actually fit this structure, and what's the spacing got to be with that bracket. So typically I'm going to start with, you find you got to have a C49S. You're going to locate the deck thickness on the overhang. It's going to be roughly 16 inches. I got that from the cross section of the plans. The hanger strength that I'm going to use, if you look inside the hanger for the bridge brackets that we have here, and an angle type bracket or hanger with a 45-degree clip on the end of it, you have options of 4,500, 5,000, 6,000, and even 3,500. Now the 3,000, 3,500, those kind of are specialty hangers that, basically, if you run into a problem, what you would have to do. The 4,500 to a 5,000 pound hanger, they are not bad hangers to use, but they are not the strongest ones in the marketplace. I like to get my biggest bang for my buck, so I always kind of lean towards a 6,000 pound hanger to make sure that I can make that one work first. If I can't, then I will resort up to the 4,500 and 5,000. So on this bridge here, because I cannot weld, I've already determined that I'm going to probably use the C68 hanger, which is a wraparound hanger, for a 2-inch beam flange by 21 inches. It has no welding to the beam. It basically clips over the top of the beam. The SIP decking guy will actually come in and cut his forming in and around the hanger. So once the hanger's in place, it'll basically be sitting there ready for you to attach the overhang bracket to. So here I picked my line out, 6,000 pound hanger. I'm going to figure out what my weight of my finishing machine is. Now here, I've actually taken a gander that the finishing machine was going to weigh 1,700 pounds per wheel load. And knowing that it is the width that it is at, I know that let's say I'm using a heavier machine, like a Bidwell 3600 type machine. And the finishing machine there using that finishing machine and the weight of the concrete here is going to give me an overhang bracket spacing of 4 foot 3 inches. But there's one small problem that you need to place very close attention to. If the overhang bracket is coming in at a spacing of 4 foot 3 inches, or let's say 4 foot, the finishing machine has a wheel spacing of 3 foot from center of wheel to center of wheel. So what happens is you now get a trailing load from once the front wheel hits the overhang bracket, the trailing wheel load is going to get transferred. Part of it is going to get transferred to that other bracket, to the other bracket in front of it. And that is going to be roughly 30%, or roughly 600 pounds roughly. So that would take it up to about 2,250, 300. So you're going to actually have to move this bracket spacing down to about 3 foot 6 inch, primarily because of the finishing machine. Now, if you have a finishing machine with 4 foot centers on wheels, you can actually run this hanger spacing at 4 foot. But because of the finishing machine, you actually have to move everything in a little bit tighter. So spacing everything around here, I basically take my 218 feet 18.6, I think it was. Divided by 3'6", I come up with 63 pieces, component brackets, plus one. So that means I need 64 overhang brackets per side. Remember, when you start out with a bridge overhang bracket, you always have to start with one. So I always take whatever my number is, and if I round up, and then I add one, I'd rather have one too many on site than one short. So 64 brackets per side, going to give me 128 of them. I'm going to actually incorporate a guardrail receptacle on each one of them and an extension on each one of them. The C68 hanger that I talked about, galvanized, because remember I said any metallized surface needed to be galvanized. So these are going to be galvanized, hot dip galvanized. So they are going to be a 1/2 inch by 2 inch by 21 with a galvanized nut, because the nut is going to stay in the hanger are both going to stay in the bridge deck when you remove everything. So you have to have that galvanized also. You can use a standard B14A 1/2 by 24 adjustable coil bolt. And then you're going to have, if the contractor doesn't have them, this is a great add-on for the contractor. It's always one of these products that the contractor a lot of times has a tendency to review and miss is cradle heads. If need be, and the contractor is looking for engineering done on it, this is available on our website. You can actually go to DaytonSuperior.com, go to resources, go over to engineering, bring it down here to where it says bridge deck engineering. This is the bridge deck information sheet. You can print this off and actually get a lot of this information right from the contractor itself, because the finishing machine is only going to come from the contractor. We will run the calculation for you. This is a billable billable item here. A lot of states actually will accept this as a pour plan for your bridge deck. So like I said, a lot of states actually have taken this and they've used it. And you can see we're actually down here, down at the bottom, because we actually went through, our spacing actually worked out to 42 inches, which is 3'6". So this all coincides with what our estimate should have been. And you can see the spacing that we had on here is our dimension of our overhang bracket is we are going to set that at 26 inches. Here, actually they set it at 24. I would have set it at 26. It doesn't matter because you're still going to have the same safe working load. The extension was put on the bracket for basically additional walkway space. And you can see this can actually be turned in also. Once again, this is also available as an additional charge with the calculation sheet and can all be submitted to the state as a pour plan for your bridge deck. We also include all of the calculations along all the tech data sheets and all of the pertinent information for all of the accessories that are incorporated within the bridge deck itself. And here you're going to be looking at our spacing. This is where we got the 1'6" spacing for the cross section of deck from the overhang, but we are going to look at the rebar size. Here you're looking at, you got a 9.5 inch deck going through. You've got 1.5 inches of coverage on the bottom, 3 inches of concrete coverage on the top of that rebar. And your rebar sizes are typically going to be placed here. You're going to have your rebar placed as to what size rebar is denoted here within the structure. So you now know what size rebar you have. You know the top cover, the bottom cover, and the overall thickness. Mathematics actually comes into play here because all this stuff here, everything we dealt with here, 9.5 inch deck, 1.5 inch bottom cover, 3 inch top cover. You got number 4 bar running throughout the deck. You're going to have space. You're going to have 3 inches of space in between the top and the bottom mats of rebar. So that's going to tell you you've got to have 3-inch upper, and you got to have 1.5 slab bolster upper on the bottom. So, or alternating number 6 bar. You may end up going with, in certain areas, if you have an alternating number 6 bar, you may only have 2 3/4 inch rebar supports, which is not a problem because that's a standard size for Dayton. So you can actually have 2-inch, and all of these components are going to be epoxy coated. Excuse me, galvanized. This is all galvanized rebar, galvanized bar supports, or you can do it all in plastic. Plastic has come a long way within the industry as being cost competitive within the job site. And so what you typically are going to have here for your 1.5-inch slab bolster, I got 4 bays, basically there's 4 gaps in between the beams. I'm going to put 3 rows in between because I got 9 foot of spacing in there. So that means I've got 12 rows of bays running longitudinally on the deck. And it's roughly 220 feet, so I'm going to need roughly 2,600 feet of slab bolster or deck space to cover. The 3-inch running across, we're going to space it at 4 inches on, or 4 foot on center. So I'm going to have about 56 rows going across to support that upper deck. We got 25 rows altogether, so I got 56 times 25 foot across. You're typically going to have somewhere in the neighborhood of 1,400 feet, where you're actually going with a 2 3/4 inch because that was alternating. If you remember on the one sheet, the overhang area had the only area that had the bigger bar. It wasn't all the way across the deck. So that you'd have to incorporate 1,120 feet of 2 3/4 slab bolster with this. And if you need to have individual chairs for the fascia, because you have a beam flange thickness of 2-inch, haunch minimum of 2-inch, plus a bottom cover of 1.5 inches, gives you roughly a 5.5-inch chair. Roughly because of the slope of the deck, you deduct the slope percentage, you're going to end up with 5.25-inch chair all the way through. And I typically like to use plastic for that. Now, the bridge deck calculation book also incorporates all of the brackets, all the safety information and everything containing that. And the resources that are available for you on any of these topics here is basically at DaytonSuperior.com. You're going to have tech data sheets, handbooks, e-marketing, product pages. You're going to get contact pages on who your sales and customer service rep is. You can also get Heidi's and my phone number if need be.
Chuck, you're not supposed to say that. I'm
Okay.
just kidding.
We're readily available to help.
Yes, we are.
And you can actually call us or call any of your sales reps in the customer service group to actually start any of these processes going forward. Once again, you can also print off the handbook if need be, or just basically download it. That's available from the website. And if you need any additional training classes, because of, let's say you're in a different state, let's say you're in Missouri, you're looking for a training on a set of Missouri plants, basically get a hold of us and ask us this. We can actually pull up a set of plans from Missouri, do a class that is actually personalized for how Missouri builds a bridge, and actually develop that training for you. Or if you're just looking to get general information on any of the concrete forming accessories, sign and forming, feel free to give us a call. That link right up there, that QIR code up there will actually get you right to a request form. Send it in. Heidi and I will get it. And if you need any additional assistance, review our online trainings and see what you're looking for. Maybe it's already out there. But we also offer any lunch and learns in custom AIA or in-person or virtual classes.
That's right, Chuck. Are there any questions? This was really good. Well, next week we're going to be doing rebar splicing, so be sure to sign up for that one. Give you just a second to see if we have any more questions. Like I told you, we record these, and so this will be out on YouTube this afternoon, and then you can get it if you want to refresh and kind of pause and look at all those numbers that he went through and figure it out on your own. I'm actually going to do that because now I'm getting more of the hang of it. Well, Chuck, I think you did such a good job. We don't have any questions coming in, but like Chuck said, if you do, please feel free to scan that QR code there, and that gets you to, the information sheet to get right to Chuck and myself. Or you could just go to training@daytonsuperior.com and it goes straight to us. So with that, I appreciate you taking time on your Tuesday, and I hope you have a great rest of the day. Bye
And
now.
I know everybody. Have a good day.